Thank you, Scott. We have our next club meeting on November 7th, and as it stands as of right now, we will be taking one of our cans and our duplexers apart. So if you're interested in what's inside a duplexer, you want to attend this meeting. That will happen at approximately 7 o'clock, 6:45, 7 o'clock, somewhere in there. So if you want to see what it looks like, come on down. If anything changes, I will let you know by the net before the meeting, which will be Sunday of Labor Day.
He said November, but I know he meant September 7th, and it should be pretty interesting. I know I'm looking forward to it. From what I understand, duplexers are kind of simple if you look at them, and we have some really smart guys in the club that have torn them apart before, so I'm kind of interested. They perform a very important function in the repeater, and that might be something that somebody could talk about. I know what they do, but I wouldn't be able to describe them accurately. And I have a feeling that John in Summersville. John, can you give us a 30-second, a 30-second or a minute what duplexers do on a repeater? I'm not saying Gary couldn't do it. It's just John's an electrical engineer, and I know Gary and I both would love to hear it. K8LVZ. John, could you describe to the net tonight the function of duplexers?
Good evening, Scott and all from K8LVZ. I do need to talk with you, Scott, sometime before you secure the net, whenever. But basically, in essence, what a duplexer is a set of filters. And they're very high Q filters, meaning that they are very narrow and very precise at 2 frequencies. And the frequencies, in the case of 2 meters, those 2 frequencies are only 600 kilohertz or 0.6 of a megahertz apart. And when we go into 70 centimeter, they get to be 5 megahertz apart. The idea is that I can use a single antenna, and in the case of this machine, for instance, we're listening on 147.000, which is what the repeater is transmitting on. So you have to be able, the transmitter has to be able to send power into the antenna through this set of filters without that power flowing back into the receiver for the repeater and cooking it. Likewise, when it's not transmitting, we need to be able to route the power from the antenna into the receiver to be able to hear what people are transmitting, depending on the machine, either 600 kilohertz above or below that center frequency. Just to not tie up the machine or not time it out. When you tear these apart, you're going to notice they are either large square cavities, or sometimes they're kind of tubes of metal. Think of thin pipes like you might use for furnace ducting, one inside the other. And as you adjust them, there is basically, at the frequencies we're talking about, inherent capacitance and inductance. Normally between the cavities there's some type of a hole or a little piece of wire or something that allows power to flow from one cavity to the other. But by very precisely tuning the size and shape of those cavities, they end up passing certain frequencies very precisely and not passing frequencies outside that range. So once again, we have a transmitter and a receiver. We want to combine the output to transmit to the antenna without frying our receiver. Likewise, we want to take the incoming signal from the receiver, put it into the receiver so it can hear what's coming in. At that point, whether it hits the transmitter or not doesn't generally matter. But it's so that we basically, if you were to just connect the output of the transmitter and receiver to your antenna, when you keyed down, you would be frying your receiver. So it basically provides isolation of power between outgoing high power and incoming very low power between the transmitter and receiver to make up the repeater. Does that make any sense to you, Scott?
And I'm certain that you described it in a way we can all understand. One comment I would make that is obvious, but until you actually see it with your own eyes, you go, oh yeah, wow, I guess that makes sense. And that is, if you put cans, as I've always called them, for a 440 machine, a 2-meter machine, and a 10-meter machine, side by side, they're phenomenally different in size, especially the 10-meter cans. They were huge. The 2-meter cans you think you might be able to carry around. The 440 cans you could set on your desk. Also, it's usually not just one, it's a series. Am I correct, John?
Correct. And in fact, many of the 70-centimeter repeaters, you just buy a box with a connector on the back, has built-in duplexers. And in fact, some of the I think that some of the Kenwood, like TMV7 or 70 series, I had one of the Wooksong 8 Deltas, has built-in crossband. Now in this case, the built-in duplexer isn't as precise because it's dealing with 2 meters on one end and 70 centimeters on the other end, so the frequencies are spread far enough apart you can do it without the cans. But again, we're talking wavelength. These, the internals of these things are going to be spread out in such a way to work with the individual wavelength, and obviously at 10 meters the wavelength is 33 feet. At 440 it's 70 centimeters, which is a few inches. So and again, once you look inside, which any of you get to look at them, they are kind of fun to look. Tuning them is a whole other story. In order to tune them both with the proper equipment, you've got a $50,000 vector network analyzer. Guys could tune up a set of cans in a few minutes. Doing it as I've done in the past with an SWR meter and a transmitter, it can be trial and error and take you hours. But that's essentially how they work, and the size is directly related to the frequency, which is going to be the wavelength. Same as if you're putting up a dipole. 10 meters, a lot bigger than 70 centimeters.
Okay, John, thank you very much. There we have our topic. So, we're going to go on down the list, and if anybody has any comments about our topic.
Yeah, I was asking, why aren't we using 2 radios and 2 antennas?
They sense each other, would be one answer. I know I have had 2-meter radios in close proximity before. I've actually had, I do right now in my Prius. I have an APRS beacon. It's a handheld into a small amplifier, and the antenna is about 4 feet from the one I talk on. And every time it goes off, it desenses the receiver on the radio that I'm talking on. So I hope I'll kick it back up to John, K8LVZ. Robert's question is, rather than mess with duplexers, why don't we just use two different radios and 2 different antennas on the repeater? I think I know the answer, but I'm going to let you take a swing at it.
Yeah, it's KLEZ. Yeah, you have to do what's called space diversity. You either have to separate them horizontally or vertically by a pretty fair distance. For instance, the Union County machine, we do have a duplexer because at the repeater site, we have a VHF receiver and a VHF receiver and transmitter. We also have a UHF receiver. So about 8 or 9 miles away, 180 feet in the air on a water tower, we have a second antenna that receives on 2 meters and transmits into the main site on UHF with a small beam. We then have a signal to noise motor that picks the best signal and passes that one through to the transmitter. Where I come from in western Pennsylvania, we didn't use duplexers because it was all mountainous. So you would put a transmitter at some point, and then you would put remote receivers, one or more of them around it on high points. And you would basically relay, the voice across the 440 link. So in a case like that, you can, but it's a case where, as you said, you can't have them. If you're doing that, you have to put them. I think it's something around 10 wavelengths in the vertical and 3 or 4 wavelengths in the horizontal in order for them not to desense each other. And even at 2 meters, if I'm going horizontal, going say 3 wavelengths horizontal, I'm talking 20 feet. Which, if I've got a tower, I've got to have an arm that reaches out 20 feet to hold the other antenna. So physically, sometimes it's just harder to locate the other antennas so that they don't interfere with each other.
I think you covered it. Another factor, John, would be feed line loss. If let's say you wanted to put on top of a building and 20 feet wasn't any problem at all, but you would have to run feed line clear to the other end of the building, I guess, although probably running hardline or something. But I guess that's I guess I shouldn't have said that. But Robert, I think he answered it. They desense each other, and I know in my car, my APRS beacon is a handheld, but it is into a 25 watt amplifier. But the frequency of APRS, I think it's 144.390, I'm not positive, is far enough away from the 147 that I normally listen to. It is acceptable. But when I'm talking much closer in frequency, an example would be 144.200 on sideband. Even though the APRS beacon's on FM, it just wipes the heck out of it, so I turn it off when I'm going to talk on 2 meter sideband.